So what exactly is this mystical thing called middleware? Well, middleware are software components that are assembled into an application pipeline. And what it does is together all of these pieces of software, these components, handle requests and produce responses, handle the request that comes in from the browser, and then generates some kind of a response. Maybe it's an exception page, maybe it's an MVC view that appears, maybe it's something else. But it handles all of the processing that's needed to handle that request. So it performs asynchronous logic on an HTTP context. Context is just something that has basically all the information about the request. So it handles the logic of responding to that request. Now, each individual component has the logic that's necessary to determine whether to pass the request on to the next component in the pipeline, and can perform actions before and after the next component is involved in the pipeline. This is where it gets a little bit complex, because each component needs to decide if it's going to allow the rest of the pipeline to continue processing. So kind of the canonical example of that is if you have authentication middleware, it can determine if the user successfully authenticates, and if the user does, then it'll allow the rest of the middleware to continue, the rest of the pipeline to execute. But if the user doesn't authenticate successfully, then at that point it can turn it around and say, okay, we need to generate a request based on you're not being a valid user. And so what's happening within each of these middleware components is that what are called request delegates are used to build the request pipeline. And those delegates handle each HTTP request. You configure these delegates using map, run, and use extension methods. So they're run something, map something, use something extensions on the iApplication Builder type that's passed into the configure method in the startup class. Now I'm not going to look at map here since it's rather specialized, but you can use these methods to branch the pipeline based on various conditions. So these reusable classes are middleware or middleware components. Each middleware component in the request pipeline is responsible for invoking the next component in the pipeline or short-circuiting the chain if it's available. And they replace HTTP modules from classic ASP.NET. So if you're interested, if you're migrating an application forward, Microsoft does have some documentation called Migrating HTTP Modules to Middleware. And that explains the difference between request pipelines in ASP.NET Core and the previous versions, and provides some middleware samples that correspond to HTTP modules. So that's a good place to start to get more information about that. Again, migrating HTTP modules to middleware. Okay, so let's talk more about this pipeline flow. The ASP.NET request pipeline consists of a sequence of request delegates, or middleware, called one after the next, as this diagram shows. And there's a defined flow from request through the middleware, ultimately to the response. Okay, so a request comes in, and it calls the configure method, which then executes each of these middleware methods in turn. So it's going to become apparent that order is important. I'll talk more about that shortly. So the first request comes in, and that method calls the first method that you define within configure. Okay, so that's middleware 1. It has some kind of logic, and then in this particular case, it executes next, which means go on to the next middleware. Okay, so then it executes the logic of the second method that is defined within the configure method. It too ends up executing a next method or calling for the next step. And so that calls the third piece of middleware. And for this very simple example, I just have 3 pieces of middleware that are defined within this startup class. Okay, so now this middleware, either because of logic or because it's terminal middleware, then doesn't have anywhere else to go. It's going to start going back up the chain. And so now it goes back to middleware 2, which may or may not have more logic that it has to execute now that the pipeline is being returned the other direction, or being traversed up the other direction. So it has more logic. When that's done, it then goes up to the first set of middleware. And then altogether, every step along the way here is generating a response, which is then finally returned to the client browser that originally made that request. All right, so there's a few things to understand about this whole flow through the middleware, through the pipeline. Each piece of middleware can perform operations before and after the next middleware component. So that's why middleware 1 and middleware 2 have more logic that executes after it's being returned. The pipeline is being returned back through each of those middleware steps. So any of these components can choose to stop passing the request on to the next delegate and instead handle the request itself. So this is called, quote, short-circuiting the request pipeline, end quote, which is a good thing because it allows unnecessary work to be avoided. And one prime example of that, as I mentioned, is authentication middleware. It might only call the next delegate if the request is authenticated and if the user has permissions on that particular request to get what was requested. Otherwise, that piece of middleware could short-circuit the pipeline and return a not authorized response, some sort of exception, whatever an appropriate sort of response is. Another example is that exception handling delegates need to be called early on in the pipeline so that they're able to catch exceptions that occur in deeper calls within the pipeline. If you put the exception handling middleware at the very end of the pipeline, then you're going to have a lot of code that's executed without the benefit of an execution handler. All right, so the ASP.NET Core MVC middleware can handle a request that matches one of the defined routes, or if there's no match, pass the request onto the next middleware, if there is any. Okay, so if it doesn't match a route, MVC doesn't know what to do with it, it can pass it on to the next middleware. All right, so you can start to see how you can assemble some complex application pipeline logic with surprisingly straightforward code. And best of all, it's defined, albeit implemented usually in separate classes. It's all defined in the configure method. So it's very easy to define the pipeline and understand what's happening at application startup and when the application is handling a particular request. And this is a really big improvement over classic ASP.NET, in which a lot of this was available, but it was pretty significantly obscured. Now, each of these middleware components can be an OWIN-based middleware, or you can write your own custom middleware. And by the way, OWIN stands for it's OWIN, it stands for the Open Web Interface for .NET. And that defines a standard way for middleware to be used in a pipeline to handle requests and associated responses. And the nice thing is that the features of ASP.NET Core make it really easy and straightforward to define that OWIN middleware. Now, one of the nice things about ASP.NET Core is that it ships with a bunch of middleware components right in the box, literally. So there's authentication, that one I've talked about a couple times, provides authentication support. Cores to configure cross-origin resource sharing. Response caching is a big one if you need to cache portions of your page. It provides support for caching responses. You can compress your responses. Routing, not available just to MVC. You can use it with other kinds of ASP.NET Core applications. And it defines and constrains request routes. Session provides support for managing user sessions. Static files is a big one. You're almost always going to want to use that because you need support for serving static files as well as potentially for directory browsing. That can be a little bit dangerous to let users see the structure and contents of your folders, but there are ways to limit what they can see. And in some kinds of websites, that's a useful thing to have. And there's also middleware that supports URL rewriting. So for most basic, straightforward, non-trivial ASP.NET Core applications, there's a pretty good chance you'll find the middleware available. And of course, this is all implemented by NuGet packages, and so there's a lot of other kinds of middleware that's available as well if you take the time to search the NuGet repository for different kinds of features that you can add to your ASP.NET Core. And keep in mind that you don't have to use this built-in middleware. Like much of .NET Core, including ASP.NET Core, you can just not use, say, caching that it provides and write your own. That'd be a fairly daunting task, but it's something that you may need to do. One thing I'm doing in a current application is that I need to authenticate against a WordPress database within an ASP.NET Core application. And so I'm not going to use the authentication middleware that is provided by ASP.NET Core. I'm going to write my own. It's going to be very simple, but it hooks into the same request pipeline quite nicely. All right, so you have a lot of different ways, a lot of flexibility in how you do things. Let's take a closer look at the standard templates, the standard project template for an ASP.NET Core application. Take a look at the startup class to see how all this stuff comes together. So I'll go ahead and open up that class. And first thing I want to do is just briefly point out a couple things within the constructor. So the class name is startup. So the constructor name, of course, is startup. There's a hosting environment that is injected into that startup class. And so this makes environment information available to this constructor. And then it uses this configuration builder to essentially read in different sets of settings using the configuration system within ASP.NET Core. It sets the base path, so essentially this is going to make the root path of the application the content root path, so that it doesn't have to worry too much about paths. It can just go off the root. And then it adds those JSON files, an appsettings.json, and it indicates that this file is optional, and it should reload the file on any change, so it can dynamically reload and change settings. And then what's interesting here is that you can also optionally include other appsettings.json files for different environments. So all you need to do is, if you have, say, a debug environment, then you can create a file called appsettings.debug.json. And if that file exists in the root path of the application, then this method call right here will load those settings into memory. Okay, and that also gives you the option of configuring the development environment. Earlier in the course, a couple times, I've mentioned user secrets. And so this is a way of keeping secrets, such as usernames, passwords, maybe sensitive network machine names, other things like that, secret, maybe API keys and so forth. Put those separate from the source code. They need to be available on each developer's machine, but then you can use this scheme in order to load those secrets. Maybe it's connection string, and add those to the builder so that that connection string is now available to the application. So there's a lot of things that you can do, and as the comment says, for more details, go to that link right there. And that's actually in the template file, so you always see that. Okay, and then it adds any environmental variables that are defined on the machine. So nice thing about this is it's really easy to configure a developer's machine for an application, can customize the environment, particularly if they're performing different kinds of tasks and they're looking at the application in different ways. Okay, and then they build that configuration object and assign it to the configuration property of this class. Okay. And as you can see, there's that public variable right there that's available throughout the application. Okay, so that's the constructor. Now let's start talking about those two methods that I've been talking about. So the first one is that I want to talk about is configure services right here. So now remember, the purpose for this optional method, you don't have to have it, is that it adds services to the application to make them available. As you can see, you get this service collection object that's injected into the method as a parameter. And so now you can use this in order to build on the services that are available to this application. And so the first custom service that's added here is Entity Framework Core, in fact. And so it is going to use SQL Server. In fact, this application by default uses LocalDB, which is a lightweight local form of SQL Server. And then you can see where it's using that configuration object, that's the one that was defined up here, in order to get the connection string. That's the default connection. And there, just to make the point, you can see how the app settings file works because it loaded app settings into the configuration file. And in the connection strings section here, it has this default connection that was defined that uses the local DB. And you can add additional connection strings here if you like. Okay, so because all this happened up here with app settings, that's available here to read that setting and use SQL Server and connect to that connection string. So that's how that configuration stuff works. Okay, then this particular application, because when I created it, I opted to use individual user accounts, needs to add the identity service. And it does some configuration here. It's going to use an entity framework store in order to read the data. And there's that application DB context that I talked about earlier, which is the object context for accessing that SQL Server. Okay, so it's adding that identity service and configuring it. Next up is it adds MVC. This is an ASP.NET Core MVC application, so I need to use those services. Of course, I could write my own provider for MVC, and I believe there are some third-party ones out there. But generally, you're going to want to use the Microsoft implementation. And so this is an add method that takes care of adding that service and configuring it and bringing it in, making it available to the application. Okay, so this is all the fairly standard stuff that you're going to want to include in pretty much all your ASP.NET Core MVC applications, unless you have some special need to replace it. But then you can also record your own services as well, and you're probably going to use a technique similar to this right down here. So what these two lines code is that it adds some additional application services, and these are used by the account controller to manage users and logins. And I'll talk more about these when I cover dependency injection in detail, because the preview of that is that what these lines of code here are doing, the services.addTransient method calls, are defining those services to be used for dependency injection. Specifically, when I request the iEmailSender, I want to provide the concrete auth message sender class. So that's what's that doing there. But again, more about dependency injection a little bit later. Okay, so that's the configure services. Again, it's optional, but real world practicality means that you're almost always going to have it within anything that's a non-trivial application. All right, so now let's talk about this configure method. Again, remember that this builds the request pipeline with middleware components. And as you can see, there's several different objects that are injected into the method as parameters. There's an iApplication builder, there's an iHosting environment. This is the same hosting environment that was used up here within the constructor here that gives you access to the environment. So you can do things like check to see if this code is running within the development environment. And then if you want to use logging, there's a built-in logger factory, and that's being injected here because the default code in the standard template uses logging. If you don't want to use logging, you can rip that out, remove the parameter, and save the overhead. But generally for most applications, it's nice to be able to log basic kinds of information about the execution of the application. All right, now, first thing it does is it sets up this logging here. Keep in mind that order matters. So it's going to log any requests and do whatever else other logging sort of things that you want to do. So after that's set up, the code invokes several app.use methods to configure middleware. And each one adds a middleware component to the request pipeline. Earlier in the course, I showed just about the simplest possible ASP.NET Core application, which made a single call to the app.run method to display some simple text. And hello world, of course. Run is a terminal request, so it doesn't pass on request processing to any other middleware, whether you include it or not. So if I were to stick an app.run in here and output some sort of text to the page, none of the rest of the middleware that I define here would be executed at all. So keep that in mind. But here instead, I don't have an app.run, but the code assumes that all requests will be matched to an MVC default route. So that's ultimately what's going to happen here. But jumping ahead a little bit, if it didn't match the route, I could continue and have additional middleware that did different things and produced different output if it wasn't an MVC call, and if it successfully ran the entire gauntlet of the middleware here within the definition of the request pipeline. Now, keep in mind that the configure method defines how a request is handled. So when the app isn't running in the development environment, this is basically what happens. It's going to jump down here. It's not in the development environment, so that the next piece of middleware is the app.use exception handler. This is the first middleware added to the pipeline after the logging, so it can catch any exceptions thrown later in the middleware. And I talked a little bit about that flow of logic a little bit earlier. Next up, it calls the use static files. This handles publicly available files, including those in www.root, things like CSS, images, and JavaScript files. Keep in mind that there's no authorization authentication in the pipeline yet, so anyone can request these. Which makes sense because the browser has to download those files, making additional requests each time it comes across, for example, a source attribute on an element within the page. Now, if you wanted to serve files based on authorization, you either put them outside of www.root, that folder that I've shown you, or deliver them through a controller action. And so you can create an action result that returns different kinds of content. So if you do it within the controller, and if you use identity, if you've wired up this middleware right here, because MVC is after it, all of the requests to those action methods within the controllers are going to have to be authenticated or authorized or whatever, however you set up the authentication scheme. Okay, so if the request is for a file, say a CSS file, it comes down to use static files, it finds the files within the www.root, then this method right here is going to terminate the pipeline. It's not going to go any further because it doesn't need to. It's able to satisfy the request. And so then it winds its way back up out of the middleware. And so that's a great example of how a single step in the middleware can short circuit the rest of the pipeline. Okay, then next up is use identity. This performs authentication or wires up authentication. If the user is authenticated, the pipeline continues. Otherwise, it's again short-circuited, and you wind your way back up the middleware. So you can start to see how the pipeline is ordered. Order is important. And then finally, come down here and use MVC. This attempts to match the request to a route. In this case, the default route, because it's the only one that's defined here, but just like classic ASP.NET, you can wire up and define multiple routes, have named routes, pretty much the whole routing system that was available in the full .NET framework. Now, think back to when I described the flow through the middleware components. Again, I can't emphasize it enough, order matters. The order in which you add middleware components here within the method is generally the order in which they take effect on the request, and when they unwind in reverse to generate the response. This can be crucial to your app's security, performance, and how it works overall. So you really need to think through, as you add additional middleware, where it needs to go within the pipeline. So again, for example, exception handling is early in the pipeline before other middleware components to wire up exception handling so that if later middleware throws an exception, it knows what to do with it. And the static file middleware here is shown a little bit earlier so that it can handle requests to those kinds of files, and it short circuits without going through unnecessary components such as MVC or authentication. Authentication is added to the pipeline before anything that needs to be protected by authentication. Okay, So now hopefully you have a better idea of how this middleware comes together to build the pipeline based on the services that you define within the application. Okay, and to complete everything, I just want to show you one more thing. Remember these services that I added here? And I said that they were, essentially what's happening here is that they're wiring them up for use in dependency injection in other parts of the application. Well, where those are used is if I come over here to Solution Explorer, and I come up here to Controllers and Account Controller, you can see that I'm using dependency injection within the constructor for the account controller. And even though I'm defining this as an interface that I want to use, and the name of the variable is email sender, this definition over here is that it knows to use this concrete object in order to provide that object that this variable references, because it needs to be a concrete object. So again, because I wired it up here, I defined that this is a service that's going to be used, and I added a transient. There's other ways to add objects for dependency injection. I can do statements like this, and then when the runtime loads up the account controller, it knows exactly what to do in order to get a concrete implementation or concrete instance of the class to provide those services to the application. In this case, to send email, to send SMS messages.